this Big Sid, Ready Electrical. You know, we always ready. Hey, but today, hey, we're gonna go on over grounding and bonding. You know, we got service equipment. We need to know what is service equipment. So we're gonna go over 250.24. Okay. 250.24. What it says about 250.24. Grounding of service supplied alternating current systems. Okay, it says the premises wiring system supplied by a grounded AC service shall have a grounding electrode conductor connected to the grounded service conductor at each service in accordance with 250.24A1 through A5. All right, now let's look at this here. So we're gonna go to the first one. Don't leave the driver line side ungrounded stuff. All right, we just coming. Take that neutral up there. All right. So where's the grounded electrode conductor? Right there. You got your U for ground, your concrete encased ground. All right. You know this. Let's say this is a house. Okay. Now, before they pour that concrete, you know, the electricians tap that rebar. You know, sometimes they'll bring a piece of rebar, they'll bend it up and put it in, you know, in the garage where the panel don't go or whatever, somewhere right there in between the studs. And when you do that, you have to, you know, before they cover that up with drywall, you have to have your inspection pocket right there. So it may be a 2-gang, you know, mud ring or something like that that they gonna put right there, you know. Yep, this is your grounding electrode conductor, you know, going in there, boom. You know, this is your first disconnect, right? So your equipment ground and your neutral bar is gonna be tied together. And you got your main bonder jumper right there. So it talks about main bonder jumper with 250.28. Okay, your main bonder jumper can be a screw. You know, it may be a screw that's provided with the panels. You know, the manufactured panel that they're using. In this case, this is just a disconnect because the new code states, you know, you need to have a disconnect on the outside, you know, of the premise to cut you to be able to shut off everything. Okay. Now, the reason why now, let's go to this here. We got this metal raceway in between your meter and your first disconnect, right on side each other. So now, so let's go to 250.92. Let's see what it talks about, you know, when you have service and service interest conductors, what we need to do. All right, we're gonna read that. All right, 250.92 services. Bonding of equipment for services. All right, the normally non-current carrying metal parts. Let me say that again. The normally non-current carrying metal parts of equipment indicated in 250.92 A1 and A2 shall be bonded together. And that's raceways, cable trays, you got cable buses for framework, auxiliary gutters, service cable armor sheet, support service conductors, all that stuff. And let's see what it see right there, number 2. We're gonna come back to this. all enclosures containing service conductors coming from that low side of that meter, boom, landing for your disconnect, okay? All enclosures containing service conductors, including meter fittings, boxes, or the like, imposed in the service raceway or armor, okay? So what do we need to do right here? Right here, we have a bonding bushing. We need that bonding bushing right there to connect this raceway. That's how you bonding that metal raceway, because this metal raceway is a non-current carrying conductor. All right, it's non-current carrying. Meaning it doesn't supposed to have any current flowing on it. Okay. All right. Down the line, we're gonna talk about objectionable currents, and that's in 250.6, and we're gonna talk about that later. Down the line in another video. All right. So now, what it says here, okay. Now you go down to 250.92B, and it talks about the method of bonding at the service. Bonding jumpers meeting the requirements of this article shall be used around impaired connections, such as reducing washers, oversized concentric or eccentric knockouts. Now on some of these panels, you have 1 inch, 1.5, 1.25, this here may have 1 inch, 1.25, 1.5, and it jump up to 2, and then it'll jump up to 2, maybe 2.5, depending on what the size of this that disconnect is, whether it's a 200 or whatever. Now these knockouts gonna be eccentric or concentric. That meaning that you can remove the knockout size that you need, and this is what this is talking about when they talk about bonding around those type of knockouts. Okay, all right. So standard lockouts or bushings shall not be the only means for bonding required by this section, but shall be permitted to be installed to make a mechanical connection of the raceway. Now that's just simple. This is a metal conduit. Let's say this is just EMT. So you're gonna have a connector on right here on the outside, and there's threads coming inside, and so you're gonna have a lock nut that's gonna be holding that conduit, right? So now you have to put that grounding bushing on there. Okay. So, and another thing, even though let's say this is a 200 amp disconnect, even if you would put this in, if this wasn't metal, it was PVC, you would put just a plastic bushing on both sides because your conductor size, which is you have to put a bushing, depending on if it's number 4 or larger, So that's another thing though. But all right, so we done covered that. So we got our grounding bushing right there, and now we have our conductors going to our sub panel. Now this is a sub panel. This is it's not a regular panel. So now we're gonna go down here to let's go back to 250.24. All right. So 250.24, it talks about 250.24 A5, load side grounding connections. All right. That's talking about your grounded conductor on the low side, grounded connection. Let's see. A grounded conductor shall not be connected to normally non-current carrying metal parts of equipment to equipment grounding conductors, or be reconnected to ground on the low side of the service disconnected means, except as otherwise permitted in this article. All right, so what they talking about, we call this floating the neutral. So this neutral is floating, so that means it's not touching this metal of this panel. And your grounds is the only thing that's going to be touching, making contact with that panel. So that's what we call floating the neutral. And you have to have those separated to make a effective ground fault current path back, to clear a fault. So that's going to be going on that ground, and it come back in, boom, to clear that fault. Okay, so that's what they talking about right there. That's why you have a sub panel. This sub panel is going to be, let's say this is a resident, a dweller. Okay, you're gonna have your meter here, your first disconnect outside, right on the side of it. So now you're gonna have a hub. You're gonna have a, let's say this is going in the back because it got to go through to the garage. So this panel is inside. Okay, that panel is inside the house. So this is where all your branch circuits gonna come from, right here, right there. And now you see that we didn't bring a ground electrode conductor down to here because you already have it here, because this sub panel is on the same premises. Let's see. Now, if this was run to a remote building, then we would have to put a grounding electrode conductor, going to we have to put a ground electrode out there. All right, and that's in 250.32. All right, but yeah, this is all I wanted to cover right here, because people, they a lot of guys don't have a clear understanding of this, when it comes to service. This is your service right here. Some people would say, okay, this your whole service. What service is controlling the power that's coming from the utility. So let's read that definition, because you want to make sure you have a clear understanding, of what you trying to understand. Let's go to Article 100 here and go to services. I'm gonna look up service equipment. See what they say right there. All right, everybody at service equipment. All right, service equipment. It reads: the necessary equipment consisting of a circuit breaker or switch and fuses and the accessories connected to the serving utility. Okay, this is connected to the serving utility. Okay, and intended to constitute the main control and disconnect of the serving utility. Right here. This is the main control that's going to disconnect power from this house, from this panel and all the branch circuits in it. This is your service equipment right there. All right. Okay, so that's what you want to do. Let's say you may have this on your journeyman exam, or even on your master's. Some questions that they ask, you're gonna need to go to this to the definition. So always, when you trying to understand something, go to the definitions and read them and see what it says, and it's gonna tell you. Okay. All right. But I think that's it. Okay, we covered 250.24, and we covered 250.92. Let's see what else we covered here. 250.92, 250, and well, let's go ahead and cover 250.64 E. Let's do that, because people, you know, I'm an electrical inspector, and I hit guys on this problem all the time, and they don't know why. But if you're watching this video, this is why. This is why I hit you. Alright. Metal conduit enclosing your ground electrode conductor. What is the code? What is the code on that? Can you have a metal enclosing it? Yeah, but it's some steps that you have to take, you know, following this code. And we're gonna get into that right now. We're gonna clear this up. 250.64, 250.64E. Raceways and enclosures for grounding electrode conductors. Number one, ferrous metal raceways, which is what this is. Let's say this is EMT, okay? Enclosures and cable armor for ground electrode conductors shall be electrically continuous from the point of attachment to the cabinets or equipment to the ground electrode, and shall be securely fastened to the ground clamp or fitting. Ferrous metal raceways enclosures and cables shall be bonded at each end. All right, I'm gonna read that again. Ferrous metal raceways enclosures and cable armor shall be bonded at each end of the raceway or enclosure to the grounding electrode or grounding electrode conductor to create an electrically parallel path. All right. So let's go ahead and get this here. What they saying on here, you need to have let's say you have your connector. You need to put a grounding bushing here, and it needs to go up. Or you can loop this one here on there, but that take a little finesse time. So you can just go ahead and go on that grounding lug of that ground bushing and go on up. Boom. Now on this side, on the other end, to make this here continuous, now you're gonna put you a clamp. And you're gonna take that to whatever electrode that you are trying to tap. Okay. And this here, and that ground electrode, this bonded, that bonded at both ends, it needs to be the same size as the ground electrode conductor that raceway is enclosing, or larger. So that's how you would do any metal enclosures for your grounding electrode conductor. I always tell people to get away with, get around all that. Use PVC, easy. Use PVC for your protection. You don't have to, I know a lot of guys, they want to bend the pipe and make the metal look good, but hey, if you're a contractor, you're wasting too much time doing all. This is more copper. What it's gonna add up. So save yourself some headache messing with that metal going around your ground electrode conductor. All right. Let's see. It was something else that we were gonna cover. And don't forget that 250.64E. Don't forget that, because if you put that in there and expect to come, don't be asking him, oh well, we was doing it all the time. I get that all the time. Well, we always did. Well, hey, I'm a different inspector, and I don't take nothing from nobody. So, all right, but okay, we covered bonding, 250.92 services. All right. Okay, we'll get into this other stuff later, and we don't have to. 250.97. You know, that's using bonding anything over 250 volts. This is a 12240 volt system, so we don't have to worry about that, you know. So let's go ahead and read that and see what it says about that. 250.97, bonding for over 250 volts. For circuits of over 250 volts to ground, 250 volts to ground, not phase to phase, okay? Not phase to phase. Because phase to phase with a 12240 system is 240, okay? And the 277 or 4880 system, you know, that you know, you got two from phase to ground, you're gonna get 277. So that's where that would come into play. All right. So it says for circuits over 250 volts to ground, the electrical continuity of metal raceways and cables with metal sheets that contain any conductor other than service conductors shall be insured by one or more of the methods specified. All right, so they have the exception down here and what you need to do. Okay, let's say where oversized concentric or eccentric knockouts are not encountered, or where a box or enclosure with concentric or eccentric knockouts is listed to provide a reliable bonding connection, the following methods shall be permitted. Threadless couplets and connectors for cables with metal sheets. Okay, 2 lock nuts on rigid metal conduit or intermediate metal conduit, one inside, one outside of the box or cabinet. Fittings with shoulders that seat firmly against the box. So that means it would seat firmly against the boxes, okay? Where we at here? Such as electrical metallic tubing connectors, flexible metal conduit connectors, and cable connectors with one lock nut on the inside of boxes and cabinets, and listed fittings, okay? So there you have it. So that's you know, that's how you would do with that. So now, and what are they talking about right there? They say, you know, this is an exception, you know, and you have to do all that stuff, okay? Exception, where oversized, concentric, or eccentric knockouts are not encountered, or where a box or enclosure with concentric or is listed to provide reliable bonding. Now, when they say that there, some boxes, if you look inside the, let's say 11/16 box, you know, for 11/16 or 4x4 box, it may say right in there, listed for bonding requirement or something like that. You know, because you know, we dealing with UL listed stuff, so it may say, some boxes say that in there. Okay, so you got to look at your material that you're using. All right. Otherwise, you will be using some grounding bushings to bond that. Okay. That's all with that. Yeah, I just wanted to go ahead and get this out the way so we can start going over some other stuff. But yeah, I just want to get this one here. Start here. Because a lot of guys, they don't really clearly understand, what to do with grounding and bonding. They don't understand what grounding, what's the difference between grounding and bonding. Okay. This is when you using that grounding bushings, that's bonding stuff. All that is bonding. Your main bonding jumper right there. That screw, that's bonding, because you bonding this terminal bars to the metal of that that cabinet, to that cabinet. So grounding is grounding. Taking something, you have an equipment grounding conductor, something that's gonna run back. Let's say you take a branch circuit somewhere 12-2 with ground. That's the equipment ground. You grounding. Okay. Now when you get to that box, you have to bond that box because you're using that NM, the Romex. Okay. So now you got to bond the box. That's the difference between grounding and bonding. Okay, you gotta understand that. All right. But that's it. You guys let me know what you wanna you wanna, if you need to brush up on something and you quite don't understand, yeah, just put it in the comments, and we'll go over it. It don't matter the section. I done taught all this stuff. In the Navy, CB, so, I was a CB construction electrician, so I taught all this stuff, so just put that, put whatever you want to see in the comments. But Big Sid, ready to let you go, I'm out. Always ready, baby.